Yeah, welcome everybody to our tutorial on how we are building a uptime monitor with MeteorJS, Fetch, React, and Plotly.js. It's a very beginner-friendly tutorial, so we don't expect you to have any big prior experiences. And in the first place, I want to show you how it actually looks like what we're building. So in order to do that, let me share my screen. And it will look like this. So we want to build a monitor that constantly updates by a given interval with 3 seconds of interval, and having a target page that we want to monitor, and then let Plotly.js automatically update the chart for us with the stats we feed it in. And then it will look like this. You have a timeline where it's up, and it's usually most of the time, unless you have a very unreliable site. But apart from that, usually that should be mostly aligned. And then, of course, there's also a response duration of your request that we want to measure in order to see also a little bit, get some insights on the network side of things, right? So, and in order to do that, it's pretty easy, by the way, to just get started. So I've just opened my IDE here for that time. And in order to do that, I assume you have Meteor installed. If you haven't Meteor installed on your system, then you can easily go to meteor.com and then just hit the getting started button, and then they will navigate you through everything in order to set this up on your machine. And once you have installed Meteor on your system, you can simply use Meteor's boilerplate creation tool by just entering Meteor, create, and then we call our project uptime. And it's starting to use the React skeleton by default. What means skeleton? That means it's a application with a minimal structure working out of the box. As you can see now, it gives you some instructions here. And the default front end for Meteor is React, but you could also use different front ends. This is covered in the Meteor guide. There are lots of tutorials and resources out there on how to use other front-end applications, other front-end engines and libraries with Meteor. And once we created that, we go into this new created directory uptime. And then we have to install some npm packages, because Meteor itself is not doing everything for you. It's doing most of the things for you, but there are situations where you definitely need some more from the npm ecosystem, and Meteor is totally fine with that. Just hit meteor npm install, and then here it comes, React minus Plotly.js. That will be the React bindings for Plotly.js, the library that actually renders our charts. Then we need Plotly.js itself. So the one is the chart renderer, and the other is the React bindings to make this all nice and reactive. And then we also need the node abort controller in order to handle abort requests in relation to timeouts. Because if we have an uptime monitor and something is not responding, then we will get some kind of a timeout. So we need that as well. And then you just hit enter, and then Meteor is installing all that. It comes shipped with an npm already that is crafted towards the version of Meteor, so everything is working in harmony. And you can use it aside your npm installation. So if you install Meteor, it will not globally install npm, but it will actually install this in a more local fashion pinned to the Meteor version. And
So this allows you to have like version isolation.
yes, you have version isolation. It's also a little bit similar to virtual environment in the Python realm. And if you come from Python, then you're actually familiar, you might be familiar with that. And yes, so this allows you to have multiple versions of Meteor on your system installed, handling multiple versions of your project. So now it has installed everything. by the way, there's a high severity vulnerability, which you can actually this time really ignore. You should never ignore them, but you can actually really ignore them. This is currently just a client-side thing that has no no influence on the security of your application right now, so that's fine for that. And what's more important now is to get your settings file. So in Meteor, you can create a settings file that is similar to .env. If you have worked with .env, then Meteor settings is very similar. You have a file that is only injected into your application as an environment variable, and then it's made available only on the server inside your application, only with these settings at runtime. And then and for now, we just create an empty settings files, which is echo JSON, empty JSON object into some file called settings.json. And then we can just give it a shot running Meteor -- settings equals settings.json. And then in the meantime, it's selecting the package versions, because Meteor also has these packages for all its nice zero config out of the box functionality, bindings and things. And then it's building the application. And once it's done, it should show us, right, localhost 3000. This is what we are now opening in our browser. And if I reload that, then you see this is the default boilerplate, what every new Meteor application contains. It's just a client-side application, no fancy things on that side. And the first of all, what we want to do is go to our IDE and then actually look in the settings.json and create some configuration of the website we want to monitor. And for our monitor, I'm creating some namespace here. I call it monitors. And then let's say we want to monitor Meteor, right? That's the domain we want. We just want to monitor the Meteor website, as I did already in the example. And so our name is, that's the Meteor website. Then we want to send a head request each time. So I'm getting into that in a minute. Just want to finish the settings file, and then I summarize what this is all about. And
Jan, where would you find out how to format the settings file?
where to
Is that in the documentation?
In the Meteor documentation, there should be a part on Meteor settings, and there should also be it's I think in the overall documentation on environment variables. So so what I'm writing here now is basically a configuration of this monitor for this website. I'm doing this in a settings file right now because for this tutorial we don't want to have now everything now configurable by user interface and everything. That would definitely exceed the scope. And we're monitoring the www.meteor.com URL. We want to have a timeout of 10 seconds. That means if the website is not responding within 10 seconds to our request, then we consider it as being down. And we want to run it each 3 seconds. And as you can see, these values are written as milliseconds in JavaScript usually. And also I'm writing the response we're expecting. That's a 200 okay response. Everything is okay. Usually some websites have a special endpoint for that with the head request, and then you get a 204 response. And what it is basically a head request is like a GET request. So it's asking something from the server, but it will not receive a body to interpret. It will only ask for the headers. And this is good for things like an uptime monitor, because we don't want to evaluate the body. We just want to see that our request receives a response. We want to use as few as possible in terms of data and network. and we don't want anything beyond that, right? This is why we're using a head request. So this is our configuration. And if I save that, and you can see already, it tells me automatically that a Meteor server restarted, because in Meteor, changes get picked up automatically. And from here, we now want to think about how actually do we want to send the data we receive from the monitor, sorry, from the monitor to the client. And I created a little nice overview in order to make this a little bit more understandable. We do a request on this external server. This external server will respond to our application. We will save this in a monitor collection, like every entry, right? The duration it took, that it was successful. And if the status changes, means the website is now up or it became down, then only on this occasion we want to save also, we want to update this status in the so-called status collection. And with Meteor, we have the ability to subscribe to these collections, which basically does only sync these collections to a client-side version of these collections in our React app. This is what we're going to build now. And it's easier than it looks like, actually. So let's just start over with the collections. Just create in the imports folder a new directory. We call it collections. And then in these, we're just creating a new file for our status collection.
And we placed the collections folder under imports as convention.
That's a convention. Yeah, that's not a strict enforcement. That's rather a convention, because there are other folders that have some consequences in regards to enforcement. If I put things in the client folder, then it will be only bundled to the client. If I put things on the server folder, it will only be bundled on the server. And this third kind of folder, imports, you could also name it differently, like whatever sources, whatever you want to name it. This usually contains files that is shared by both of them. And this is what we want to do with these collections. Meteor internally handles if this collection is a server collection or a client collection. So what we're going to do is to create a new collection. We import actually Mongo, but not from this local, but from meteor/Mongo. And then exporting and creating the function in one line is basically export const status collection is new mongo.collection. Oops, sorry. And we have to give it a name that will be also the name you access in the database. I'm just calling that status right now. Okay, we do that the same with the monitor collection. So creating another one, monitor collection. Doing the same, you can easily copy that and then export monitor collection, new mongo.collection, and we name it monitor. Okay, so we've created these collections. And in the next step, we want to have a dedicated way to, how to say, feed the data into these collections from our requests. So I'm starting this today a little bit more from the backend and database side, and then we go to the front end later on. And for that, I'm just creating on the server, very important because we don't want this to be on the client. I'm creating a new file named monitor. And in this monitor, I'm importing a few things. I'm importing Meteor. I don't know why it's now auto-completing these local things, but it's okay. And then I'm importing my status collection. And I'm importing the monitor collection. So, and I'm also exporting something because the outside, the responses will be stored somewhere, and we need, in order to handle that, I export something I called monitor. That's an object right now. So that's a little bit different from a class. If you come from classic OOP, you would do everything in the class. In JavaScript, you don't necessarily need to do that. You can just write an object, and it's a little bit like a singleton without the life cycle. That's fine. And we want to initialize it when the server starts. And in order to do that, I'm writing a function now. It's called not meteor, it's called monitor.init. That's our initialization function that will always run when the server starts or restarts. And it's an async function because MongoDB transactions, insert, update, remove, or fetching cursors, they're all async operations. And so we write this also in async. And what we want to do is we want to, if a status for some website doesn't exist yet, we want to create it. And if it exists, we want to update it with our settings, because that's when I'm coming back here to the settings. We want to update the status also with these, of course, because we want to show on the client, hey, these were the settings we used in order to monitor the website, right? So name, URL, method, and interval. That's fine. And what we do is status collection.upsert. So upsert is a combination of insert and update. Basically means if something by a given query exists, then we want to update it. And our query in this case is the name. So if we have a monitors here, then let's say this monitor by name Meteor. Could also use lowercase. That's a little bit more close to the key. So no confusion here with this name. It looks for if in the status collection something with this parameter, with this property name. And if it exists, then we want to set the updated values from the configuration. If it does not exist, we also want to set the values into a new document, which is why we need to use the name here in the set as well. We can't leave it out because then it will never get inserted for the case it doesn't exist. So we have written in one line an insert and an update. That's what happens on the server start. I will show you in a second how that looks like. And there will be another function where we add a document. But let me first go on the main side, and I can remove that here. This is basically just boilerplate code that was created by the default app. I will simply delete that, but keep the meteor startup here, because this is what we want to keep. And I'm importing our monitor, and then for the monitor, basically what we're going to do is we are waiting for the start, await, monitor init, and now we want to pass our configurations from the settings here. These settings, we want to pass them into our initialization function. And we can do that by entering meteor.settings.monitors.meteor. It's a little bit, looks a little bit confusing when I read this now, but again, you can open that on the right side. As you can see, it would pass basically this into this function, and then it initializes the collection. So if I start that now, everything looks fine. If you want to confirm this, you can open a new tab, go into the project, and just enter Meteor Mongo. I think it will not work the way that it does. So I can say db.status.find1. And then you can see, okay, it exists in my database. Everything is fine. It also has an ID assigned. Everything is good. So no worries on that. You can close that. We can go back to our monitor and continue work on it there.
And just so that people don't get confused by this, when you put db dot, the next thing is the name of the collection. So, you know, that's not a reserved word. in Mongo
Correct.
primary language. Yeah,
Correct. That was status. That was the name I assigned to the collection here as
that's right.
its name. Correct. Good that you reminded me.
It can get confusing, right? Because there's
Yep.
so many methods that will have something like the
Yeah.
name status on it, and
True.
yeah.
And the next function I'm going to write is, it's not meteor, it's called monitor.add. Oh, the namings are very close. That might be confusing. I hope nobody will confuse them. So I'm writing another function, and what we want to do is adding documents that will be a result from our monitor. And without modeling these documents or modeling anything right now, we just modeling business logic here, right? So I have a function and I want to pass some kind of a document that represents our response from this monitoring cycle. And it should give us some kind of, it should give us the name of the website we monitored, like not the URL, but actually the name, because like here, these name, the keyword for association. Then we want to have some kind of a state, like has timed out. Has it timed out or not? This is important in order to switch from up to down and from down to up. And then, of course, we want to know the duration it took until we got a response. And if some error occurred, we definitely want to track this error in order to evaluate what's happening there, actually. So these are the values that will be definitely interesting for us. And if such a document comes in, we need something to compare it. And that's the status document that we have saved, right? That's the status document from this status collection. So we say status collection find one async and then by name. Why I'm doing this instead of some ID? Well, I don't know the ID of this document. I just know the name and I just want to have one document by name, which is why we're using these upsert collections here. There will be only one document by this name. So this gives me the exact status for this website by key. And then what we're writing now is a flag. Is the status has changed? And we can just check if that status has changed if when the status document we have is up. So this is also a property I just made up here. So usually it should be here as well, by the way. So by default, oh no, I don't add it here because that's the thing. Why I'm not adding it there? Because my initial configuration or when restarting the server should not affect if it's up or down. This should only be set in these methods when we actually monitoring something. By the way, this is a good use case why TypeScript is good, because then we already would know that up is some part of this collection, right? And if this collection has a status up, but the current document indicated, the current response indicated that it has timed out, then what we basically have is we just went down, right? And before going into, before continuing writing here, I just on the want to write the opposite case. So if there is not status.app and we haven't timed out, then we're back again. Yeah, so status up was false, but we haven't timed out, so the response was successful. We're back in business. So now it comes into play status changed. Status changed should here, in this case, be true, and should also in this case be true. Because we only want to update the status of our website if it's up or down once when it changes, and not every time we do a request. That would cause our database to run every time. We just want to have it once. So if the status changed, then we update the status document, the status collection. Status collection, update async. And our selector is now actually status.id, our document. Why? Because when we get the document up here, we also know its ID. So we can definitely update only this very document. And what we want to do is we want to use set. And what I'm going to do is I'm just setting status. But it wouldn't change anything, right? Why I'm setting status? Because I'm just doing it easy for me. So I would just write here status.app
So,
equals.
and we can use update in this case because we know that the record exists, the document exists in the in the database. Yes.
Yeah, correct. We know that it exists because we get it up here. And
Okay.
because we initialize this at the very beginning of our server session, because this is what happens here before. This is what will happen here on Meteor Startup. We initialize. There will always be some status document unless we delete it somehow, somewhere. But I assume you're not doing that. And this is also beyond the scope of this tutorial right now. But
Sure.
this is what we did. And what, just a question now, what is also very beneficiary inside this block? What could you implement here? I can.
What do you mean?
Okay, the status has changed, and we only do this action, updating the status document once the status changed, and then it's down, 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 but we don't update anymore. There's also
then we want to also reset the status changed flag, right? Because
yeah, we don't need to, because in the last part of this is just local within this function. That's fine. We will not care about the status change outside this function anymore. But what I wanted to say is at this point, notify user, because usually with a monitor you want to get an email, hey, your website just went down. That's this point is where you want to notify the user, because you don't want to notify the user every time like it's down, it's down, it's down. You just want to notify when it switched from up to down, or you want to notify the user when it switched from down back to up. Hey, you're back in business, cool. And one thing that is missing now, and this is what we always want to update in order to get the graph, the nice graph I showed you at the beginning, is we also want to update the monitor collection with this document. I say await monitor collection dot, and how to, in this case, we just insert this document. So basically, every time we do a request to a website and create a document out of this, we want, by the way, there's no need for these two right now. You could send the error and stuff here with, but we just want to save the whole document, the whole result of our monitor cycle. So that's the more general part of gluing together the collections with some kind of a logic on how they will be updated. And one last thing we need in this file that is very important is we need to make this data later on available on the client. We say meteor publish, and I'll just call it status. And I'm writing a function. And now let the user provide, or let the client provide a name of, it's the name in terms of like these names we use here for our monitor context. And then we would just want to return what this status collection finds by this name. So this is not a fetch document, but a cursor. Even though it will contain only one document, we just want to monitor on the client this very document. But that's how Meteor works. It will publish this cursor, being the basis for synchronizing all the docs that are in this cursor to the client-side collection that subscribe to it. And for the monitor.
Wait, hold on. Why do we want to return the cursor rather than do a find one or fetch?
Because when you fetch it, then you actually have the documents already fetched.
Yes.
And then you have one database activity extra, and you can also in the publication, you can send simply a plain array of fetch documents, but you need to use the cursor because Meteor internally will use it to observe this cursor. They will build an kind of an observe sequence, observing changes in the collection that fit this specific query. So every publication basically observes a collection by this query and sends the changes, additions, updates, removals to the client. And we have a very simple case here. So there's just one document it will observe, and it will only track the changes. So it sends the document once to the client and then just sends the changes there. For the monitor is different, because for the same context, the same name of our, like the target we want to observe, we have a multitude of monitor documents now. So what we're going to do here is we return what the monitor collection finds, also by the same query, the name, but we want to limit it. We want to limit it by 250 documents, because it will every 3 seconds, that's what we did in the settings, will it send us documents to the client. And also, let me go to a new line. Also, we will only want to have the newest document. And there is a little trick in MongoDB. You can use a natural hint set as -1. And this allows us to query from the end to the beginning and not from the beginning to the end. So you don't need to use a sort operator, which would be one more operation on already a created collection. So you can just use from you always get the 250 news documents without any extra effort. It's just it's the same effort. So this is now our monitoring class. But what's missing here now? There are 2 things missing. And that's, of course, the rendering on the client, but that will be the last one. But actually, we need to request something. This is what we didn't wrote yet, right? And we need to glue them together, obviously. But in order to create a request, I fiddled a little bit around, and then I came up like, this time, let's use a class, because we will have many instances of the same thing, basically. And so what I'm doing here is like export class uptime request. This is basically the class that will represent one cycle of requesting the server by given configuration, getting the response, and then passing on the important things that will matter to some our monitor actually. And again, we will use our configuration. So the one we put in the setting name, I can also open the settings file. So maybe this is easier for you. It will be the name, the method we use, the URL, the timeout, and the expected response. And then what I'm going to do now is just saving these configs here, and to speed these a little bit up, I'm just pasting them here. So I renamed this expected response because response might be very ambiguous. And then instead of this, I use actual response, which is now null. That will be the actual response we got from the external service.
From the fetch?
Yeah, from the fetch. And then we also want to measure things. So it's results with a timestamp, with performance measurement. I will show you in a minute what this is about. We have an error. If an error occurs, has timed out. And this is the raw response. I could also rename it to raw response, just keep it response here. And we will have 2 functions we want to implement. I call it one method, call it fire. That's actually the one that will fire the request to ask for something on the external server. And we want to have a function called toDocument. And this will make out of this one here a document that will fit what we need here, right? And what will also be passed in to the database here. So we can internally do many things, but for the outside world, we want to have certain format. This we do with this function then. And now it's getting interesting. because this is something of the fetch API. If you haven't used the fetch API before, you can just check on the fetch API on MDN. It has a very thorough documentation on what it can do, and with certain examples. It's basically doing an HTTP request to an external server with lots of configurations. And around this fetch, we want to do some performance measurements, right? Before I do anything, I will start. How do we want to do this? Do we first want to start with the fetch request, or do we want to add the performance measurement already?
I would initiate the performance measurements, right?
Okay, then there's one thing. The very first is of all, I want to set the timestamp, because that's the point the request starts. So that's the point where the timestamp is added. We don't want to use it for any performance measurement, but this is just a timestamp that later on will give us the x-axis on our Plotly graph, because Plotly automatically interprets the timestamp and then just puts everything in the right order. For performance measurements, we use a built-in performance observer that's actually not from Meteor, but from Node.js. So Node.js has something called performance observer. And this is basically a tool that allows you to run, to set a mark and then a later mark, and then it allows you to compare these in a performance critical way. So this is much more efficient and also much more precise than using, for example, dates or something like this. And what I'm going to do here is basically just in order, don't ask too much on the details, because there are tutorials on this. What I'm basically doing here is I'm doing the standard performance entry. We're just doing a measurement between our entries, and I will just put 2 entries in there. So don't think there will be thousands of entries, it will be just 2. But that's totally fine. And then in order to use it, we need a start and an ended label. Yeah, so don't get too much confused by that. Just take it for granted. And if you're interested in that, then you might look for a tutorial or something. I'm creating a label for starting our performance observer and a label for ending. And I'm using, in order to make this understandable for everyone, if you want to track it, I'm using this name. And there is one more thing I'm going to use, that's the abort controller. Abort controller is nothing fancy as well. That all sounds so fancy, but it is pretty easy. It's just a tool, or it's just a middleware class, I could say, that I'm setting into the fetch request. And if some timeout exceeds like our 10 seconds, then this abort controller gets notified and it will abort the fetch request. That's basically it. So this is what we need. And now we come to the fetch options, right? Fetch options, the method is this .method. By the way, if you want to read on what options you have, again, there's plenty of stuff you can do, like method, the mode, course mode, the cache, credentials, headers, setting redirects, how do you want to follow redirects, body, but we don't want to do that. We just want to set a priority to high. We want to error on redirects. We actually want to monitor the website and not whatever they redirect to us. So sorry, error. Yes, and this is now interesting here. That's called signal, and that's from our abort controller, a property. This is what we pass in order to time out this, to abort the fetch request on timeout. And I immediately write this now, because usually the timeout should not be too short, but you can try with a timeout of 100 milliseconds, but I'm setting a timeout here. And what it's do is it's setting this has timed out to true. This will be the case if our timeout exceeded, and the controller should abort. That's what it will call. And the set value is this.timeout. This is actually this is the value we will get from our settings here, like the 10 seconds, for example.
Now, do we have to import any of these things into this file? Because I don't remember us importing.
No, we have to import a few things right now, and of course, but
Okay.
not the settings. It's good that you remember me on that. So what we need to import here is fetch, because I don't know why this is happening, but that's okay. Because Meteor provides basically a node fetch for you. And
So we're not using the node fetch. We're using Meteor's bundled version of it.
Yeah, because Meteor bundled fetch, in order to have an isomorphic version of fetch, you have node fetch on the server, and you have WG fetch on the client as a polyfill for all the browsers that still don't support fetch. And then you can just import this package, and it will resolve to whatever you need, be on the server or on the client. And then we use a WAD controller. We just installed that. In the next Meteor version, this will be part of Node, and then you're fine on that. So we have the performance observer and performance from Node perf books. Yeah, these are important, and then I will get to that in a second.
Okay.
This is also an ID from the timeout. We need to do that. And now we are finally at the verge of a request. So we are surrounding it by a try catch, just to be safe. Equals error. I think because of these, like redirect error, and because signal abort actually will cause some kind of an error, we always need to surround this now in a try catch. And then we run performance.start, because just before the request we want to sorry, not performance.mark. That's our first mark. It's just a label, and we could set more labels, but we just want to measure start to end time. And now we finally get some response, which we await using the fetch request to the URL we're passing in. The URL is what we configured here. We pass it in, and the options is what we defined here. And in any case, which is using the finally attribute of try catch, in any case, we want to measure the performance of the request, like how long it took. If it timed out, it took obviously 10 seconds. And we need to clear the timeout in case it didn't, because what happens if you don't clear this timeout? Then every request, even if it gets a valid response, will call this after 10 seconds, causing you an error. So you need to clear the timeout as well. And we want our performance to measure, basically, something. We flag this with this URL. It's just a flag, no worries on that. That's the name, basically, and the ended. And we disconnect the observer. And what happened basically is, if I'm calling this, it will basically run this. So at this point, it's just because it's callback style async, and it will basically gives us the performance. So at this point, this dot performance should have something we want. Now we are also comparing the responses. So actual response is this dot response dot status. I'm using a question mark here. It's the optional chaining, just to make sure that there is something that this doesn't throw, even if this response wouldn't exist. And we just do a simple post checkup, right? If there is no error and this actual response is not this expected response, and expected response is what we put in here, right? That's a 200 response. If the actual response is not the expected response, then we just set another error here. I don't know, like response mismatch, and then actual response. Sorry, it's for expected response, and we're pretty done here now. That's good. So what we want to do now is we have lots of information here we don't need to set in the database, right? We just want to have the relevant stuff in the database. We want to have in the database something that can be represented as a document. So I'm just writing another function here that returns all the results that are relevant, like the name, the response, expected, and actual, and when it has been fired. It's the timestamp. But we don't need to save the timeout and stuff, because this is in the status document. We don't need to save that each monitor document. So why I'm just separating this so you understand. We're saving these monitor documents like many times, like each 3 seconds a new document. But we don't need to the method, the timeout duration, all that stuff. We save this in the status. That's fine. Unless you want to do some analytics, deeper analytics, you can save that. But for us, we want to be sparing data. We want to just use the minimum here. We want to save a duration. How long did it take? And this is basically this dot performance optional chaining duration, or 0. So if there is no performance duration because of an error or something, then we want to just set this to 0. Then we know it's just, there is no 0 latent, there is no 0 milliseconds for request response unless you're on localhost. Even then there is not, maybe. And so that's fine.
There's going to be something.
Huh?
I said there's going to be something. There's going to be some duration.
Yeah, has timed out. We just convert it to a Boolean, so it's always a true or false, because maybe it's undefined or null. And an error if we have an error. That's fine. So this is now basically our class that doing one request to an external website, gets the response, does some measurements, does a timeout, aborts the request, and so on, and creates a document that we can place into the database. I just see that this one is wrong. So, and now we can actually finally put that into our monitor. In order to do that, it's basically like that. We are just writing a function called run monitor, yeah, and it's an async function, and request is a new uptime request, and we also want to put into this uptime request our configurations. And because we do that, our uptime request will get the correct name, method URL, timeout, and response, which we put here in the settings document. This is why we're writing this. And then we are running await request.fire. That's the fire function. I can also open that on the right side to make it a little bit more understandable for you. So then we are calling this fire function. And at the end, we want to add the result from our request as a document to our monitor. So we get this document, name, response, fire duration, as fire time up, and so on, to the monitor add function. And again, this function received this kind of document and then changed our status and also adds the document into the monitor collection. So we are now finally on the server. Done so far, are we? No, we are not. Sorry, I forgot one thing. And this function needs to be run. And we want to run this in an interval, right?
Yeah.
So you can see now what I'm going to do is const my domain equals, I'm just making this a little bit easier to read. Just putting that into a smaller variable. Okay. We need to run this in an interval. So there is this meteor.set interval. It's like set interval, but wrapped in a Meteor environment, having our run monitor, that's the function, and the interval is defined by our settings. So my domain dot interval. Again, my domain is what we get from settings, and we've set there an interval, 3 seconds. This is what it's doing. And now it's running every 3 seconds. We don't see anything here because I didn't put any traces in there. I could put a trace in there. I could just open these, for example, I could say monitor.add, and then I could just run here console.debug monitor add, then like document.name, document.url, document, oh no, not document URL, sorry, putting here status.url and document duration. Then it should, and then say meteor.com, 525 milliseconds it takes, but it's up because, is it up? I don't know. I can put there on and ask.
Yeah.
That's not up. You can just see that. It will give that it will tell us in a second. Oh, it's undefined. Oh, it's undefined. What happened there? What did we miss? What did we miss, actually? So with status up has been defined here. Status changed, might be here. And with set. Oh, I get it. That was wrong. I was setting status as a property, but status, I wanted to have it the whole document. So
Right.
sometimes you need to be aware of things like that, of course. So you saw just a live debugging. So now there should be in the next one. Now it's true, right? Because now it sets the right document, Because in $set, it expects an object from you.
So the first time it runs through, there is no status document there, right? So that's why you get the undefined.
Yeah, the up property is not defined here because we don't want to influence the up property as a default in the upsert, because then we would influence it on every time we restart the server. We only want to influence it by our response documents.
Okay.
And now it's on. So now we have the server part done. And now you think like, oh my God, so long. And now you have to write the client stuff. The good thing is the client stuff, the client side, is just one page. It's so easy to add. You just go into imports, UI, app.jsx, and this is the default here, right? And I'm just deleting these I'm just deleting these. Okay, and I'm saving this. And when I go back to localhost, you just see, welcome to Meteor. There's nothing going on. The first thing I'm going to do is I'm importing my client collection, the collections I've written in the shared folder. I can import them to the client. It will not import all the data of these collections. It will just allow me to handle data I subscribe to on the client. And how that's done, I will show you in a second. I will also need some React hooks. If you're not familiar with React hooks, you should definitely watch a few tutorials on them, and because they're like essential to use React. But these React hooks are some special React hooks that are provided by Meteor out of the box. They're called use tracker, use subscribe, use find, and they are imported from Meteor/React Meteor data. That's a special repository that comes out of the box with any React project you create with Meteor. And then we want to import plot from React Plotly.js. So this is what we're going to import. And what we're doing now is I want to write the name. I'm doing that the easy way now. So the name of the domain we want to subscribe to, where we want to get all the monitoring documents from, is called Meteor here, right? So in lowercase letter. So first of all, before sending anything to the client, let me first do that. Before sending anything to the client, I want to check if my status is loading. So I'm running status loading is use subscribe. And that's the thing, what it's doing in the background. It's subscribing for you to the publication that sends me the document. That's observing the changes and send me all the required documents to the client. And this is called status. That's not the status collection. I should have named this maybe differently, but that's actually this one here. So when I say I'm subscribing to that, I'm subscribing to any changes on this query. That's cool. And why it's called status loading? Because it returns me a function that allows me to determine if this subscription has synced all the documents to the client or not. So if it's true, then it's still loading. Then it hasn't synced all the documents here. So what I could do is I could run, for example, I could write here like status loading, then like loading, and otherwise, hello, running this. Give me a second. What did I do wrong? Did I do wrong something again? That's way. Oh yeah, okay. It loaded so fast that I don't need to say. It didn't say loading. It was just too fast. But we will need that in a second because we also want to subscribe to our monitor documents. We want to get the latest 250 documents, monitor docs, and monitor loading. It's called monitor loading. Is use subscribe monitor with the name so something like this, and these are basically our two loading indicators. Okay, assume they will not have they will be loaded, then there will be some documents we want to fetch, right? And Meteor provides also with this use find already a nice way to get them. So I say not use find, it's the one status document, there will be only one because we only saved one by our name, will be called by use find. And the callback of use find is a function that resolves to status collection dot find. It will only return one document because we subscribe to it and by the subscription, it will find all documents by this name, but there will always be only one document by name. We will not add a new status collection. We will just update it. So we make it easy for us. We don't need to traverse anything. It's just the first document it gives us.
But that's giving us a cursor to that document, right?
Yep.
Okay.
And I mean, I could let me do this, so that makes it a little bit easier here. Look, we run the name monitor for name, and we just let's write something called status info. Okay.
Okay.
So the status info gets the status document, and it will also check if status is loading or monitor loading. Okay, so and what we basically do is we just write another component, const status info. It's just another React component. It's a pure component. It's just getting something, has no state, just rendering things. Yeah, and then so the first line, it's just like if it's loading or there's no status doc, just return status is loading. Okay.
Okay.
And if I reload, you see,
Yeah.
it
It
was
flashed
for
very
a
quickly.
short second. It was loading. So now there is there, and then we can just display what's in our status document. I speed this a little bit up. I mean, you can read this up in the tutorial. We will link it. It's basically just putting some stats here. The stat, if it's up or down, the URL we're using, the method, and the interval, of course, divided by 1,000 because we display it in seconds. Now, going to the website, and you see now status up, URL is meteor.com, our method is head, and interval is 3 seconds. But now this is just the status. We want to get some graphs. We want to see the the graphics, right? And for that, we need now something else. We need the tracker, the meteor tracker. That's our reactivity tool that can run a function based on data that has changed. It's a little bit similar to publish subscribe. You have some kind of observer involved, and you do something once it's changed. In publish subscribe, you update your client collection. And with tracker, we just run a function if data has changed. And we want to get 2 charts called update and duration. For the duration, not update, sorry, uptime and duration. And then we use the use tracker, run a function, and we want to run this function once. And that's the interesting thing. It's like a use effect, and it's still running all the time. Something changes, but I don't want it to run on and based on any external changes, because the changes are tracked internally. So I want to get all the docs from the monitor. And why I'm using .find for every of them, because the publication on the server, this defines exactly what kind of documents are sent to the client. So on the client, I can be very loose. I just want to use all the documents the server sends to me. And because this is capped to 250, there will be always the newest documents, and then the older get out. That's fine. And now is one thing, there might be the case that they are not in order sent to the client, because every document gets sent by each other. Maybe one is bigger than the others, and then you have your order changed. And this is where we use a sort. The good thing, and by the name fired, that's our timestamp. We want to use it. We want to use it from the latest from old to new. And why this is fine on the client is your browser has lots more computation capabilities, and it's just doing this for you. If I would do a sort on the server, for everyone who is monitoring, running a monitor on my server, that would be much bigger load. So this is fine on the client. And now comes the Plotly part. If you haven't worked with Plotly.js, it's a great tool. And it's basically, yeah, it's basically creating so many beautiful graphs for you, no matter what you put in. And it has a very, very easy to understand API. So what we want to do is we want to create a line chart. Yeah. And for these line charts, it's very easy. You have two traces with X and Y axis, and you define what kind of mode you want to have. And Plotly is doing the rest for you. There's no big thing to do. Of course, we're just using the default here, but that's fine. We have two graphs. We have the one for the uptime. Yeah. So uptime is, it's X and Y. And as a type, we use scatter. And we have the one for duration. And we'll also have, it's basically the same. You can just copy that.
So let me ask you, when we saw the graph at the very beginning of the application running, it looked like a line graph, but you're saying that was actually a scatter plot for
that's how Plotly, that's basically how Plotly internally has name for them. So this is some API specific to Plotly. It's not the classic scatter plot you might know. It's rather a line graph, but it's the default one with we going here. So what you see here is it's actually, oh yeah, it will resolve to what we need basically.
Okay, very cool.
And I think it's dots plus lines basically. What we need to do now is we have some documents here, right? These are the docs we got from Monitor Collection, and we don't need to fetch them because we can also iterate the cursor with docs for each, right? And we have a doc and an index. So that's how for each works. And what we want to do is uptime.x, so this one, yeah, pushes the fired event. So on the x-axis, we want to say on which date, like because we want to have this from left to right in our duration. And we also want to do the same actually on for uptime as well as for our duration plot. And on the uptime.y-axis, we want to push simply, that's really easy. Doc.has timed out, and then we just push down. Otherwise, we push up. So this is not a numerical, but a categorical one. And that's the cool thing about Plotly. It just resolves this for you. It just magically does this for you. And we do something similar on duration, but in this case, we don't push the names, but we just push, if it has timed out, we just add a 0. Otherwise, doc.duration. And finally, these two options, return uptime and duration, this is what this function returns, will be resolved into these. Finally, the very last step, we need to pass this into our plot. That's the one we imported here from React Plotly, right? We imported this, say data is uptime and layout. I'm just copying a nice layout here. I'm copying them both because it will take a little bit more time otherwise, and I don't like to have these writing errors. So you could even general abstract that, right? So you have one plot for uptime, for duration. You have a layout with a default width of 800 and height 400 for both. One is titled uptime, one is titled duration. And we use this config is responsive. So in order to have them responsive. And now let's take a look at our website. Whoa, it's already there. This is how it is looking like. And I hope the folks on the Meteor website are not confused that somebody is constantly requesting something in a 3 seconds interval. I will later on talk to them. So this is also one thing. Please only monitor websites you own or people you know, and so that it's always legally safe what you're doing. Apart from that, there are reasons you want to monitor some external website. Maybe you rely on them or whatever, but please stay in the legal realm. All right. So as I showed you this now, that was a very rudimentary level. So there are so many things you would build on top here, and MeteorJS offers a lot you could build around here. I mean, are there any things you could think of you would want to build around such a monitoring solution?
I think it's really cool that you got this. So what I would do is I would also want to add in perhaps like parameters, right? Where if there is a certain amount of downtime, but it's just for maybe a very short period. I don't have any kind of automated action, but if it goes beyond that, then perhaps what I would do is I would actually try to either, I might assume that the application is dead or it's in a zombie state, and spin up another container or something based on the statistics that are there. So I can use this to, create some kind of actionable idea, actionable plan in order to automate how I maintain uptime on my servers. So that could be one thing. In the old days, we used to send notices to beepers to let people know that, hey, there is something going on here. There is also the idea that you could, for instance, track, like for a while, the general use. And so sometimes there might be issues where you have typical spikes because it's just the way the server is being used in the day. And so it's really not anything to be tremendously concerned about, because you are going to get some drop-offs here and there because of maybe you don't have enough and your budget doesn't allow you to buy more servers, so you live with it, right? And I can see perhaps putting in a feature that allows you to say, okay, between Sunday and Saturday, this is what the profile looks like of a typical week. And then keep a reference profile and put that on the graph, and then show the actual that's happening in your current week, and be able to say, oh, by the way, there is something really different going on right now that I need to pay attention to, right?
And that's the cool thing here, right? With Plotly, you can easily build lines like these. You have that we just created a graph where one line was on the graph, but as you said, you could want to have multiple lines. You could easily do that with Plotly, and our infrastructure we just built on the Meteor server would allow us for that easily, because we could just say everything has a timestamp, and these timestamps are for exactly these use cases. We could just say, okay, give me from the last Saturday, or like you run your aggregations on your MongoDB pipeline, aggregation pipeline, and then you say like, okay, I have the last 56 Saturdays, the whole year, right? I'm doing a normalized version of it, like with some images or whatever, and then I'm sending this as static data to the client. I don't need to subscribe to that data anymore because it's not kind of a live data. I just need this data as static and just subscribe to the current live data, and then I'm comparing them.
That's right.
And this is where Meteor, I think, as a tool, where Meteor as a tool shines, because this is what Meteor allows you to easily create. That you have this mixture of static data or aggregated data you can using methods, and at the same time mix in some kind of subscribed, observed data.
And that's the cool thing about the reactivity also, which is it can be very selective, right? So the thing is, you don't have to have, I mean, you could have your graphs there, but you could also have your Meteor server basically, reactively updating you on some out of bounds activity only when it happens, because the computation is happening. And if everything falls within some normal parameters, Meteor doesn't do anything. But if it falls outside of those parameters, then all of a sudden, it could either you may have the web app on a screen, or you may have a mobile app that you could just fire an event to when something goes out of bounds. So reactivity is not always about every second, every moment.
No, of course. But that's what I was trying to implement with the status has changed. So that is changed once. So if so this is a selective reactivity in that case, and then I would also only send an email once the status changed, and then once it comes back, or as you said, you would then do an API request. And because Meteor is running as a Node application, so if you deploy a Meteor application, it's just a Node application as every other Node application. You can use everything the Node ecosystem offers, right?
It's terrific. Also, I mean, this little app I think is really cool because you pay for services like this.
Of course.
And
no, I don't.
Yeah, I know you build your own, but you could take this as the basis, because in many cases you don't really need a huge amount. You just need to know whether or not your application is running and what has been happening over a particular duration. I think one way somebody could take this and extend it a little is, some of the settings that we have at the very beginning that you put in terms in the settings file, you could have defaults in the settings file. And then you can have an admin page that allows you to override those defaults. So instead of having a 3-second update, you might want to change it to, maybe every 2 minutes, because you don't need it that often,
Of
right?
course not. That was I just wanted to give you now a little bit of insight on this reactivity, and 3 seconds was a nice interval to see.
It's a very nice interval, absolutely. But my point is that, if you are, for instance, doing this tutorial and you want to make it really useful to yourself, then there are ways you can extend this. If it's only you doing it, then it doesn't have to be an admin page. It could just be, parameters that you set even in the monitoring page, But I think, the more secure way to go about it would be to use something like Meteor accounts and create, an interface to an admin page that allows you then to modify these settings. Because if you put the settings too wrong, like you have it running every millisecond, then you can really slam your server, right?
Yeah, and if it's or you could create an issue if we would have done that.
Yeah, your hosting service might end up getting like a flood attack, like a head flood attack.
Yeah,
you might not make it very popular.
No, that's true. So that's again why I said please act within the legal boundaries, because you can create many tools. We can create many tools that are also used in a bad way. So at that point, I would like to close up and just do some summary with this tutorial. You should be able now to have a basic understanding of Meteor publish and subscribe, and also a little bit about collections and how the server-side code actually projects into the client-side code on this reactivity base. So it's not a magic. We refer to it as automagical sometimes because it feels so great to have it all out of the box. But in the end, it's some kind of observing pattern and allows you to do some fancy stuff. Meteor 3 is coming soon. Then you will also enjoy it on ARM. Then you can have your own monitor running on your Raspberry Pi, for example. And that's all fine.
Oh, that's pretty cool.
And with that, I think if you don't have anything else to say,
I do want to make a couple of observations here, which I think people should, keep an idea out for. I'm stepping on words this morning. I apologize. One of the things I think you'll also notice that was done here is when the code was written, Jan made sure that when he was pulling data back, he was also filtering and limiting the amount of data that he was bringing back to the application. And this is really important because as your database grows, if you don't do that, you will have a huge amount of latency in terms of how long it will take to get the data back. Because as the collections grow, it starts growing larger and larger in memory. And then also that will have an impact on how it gets recomputed and displayed on the screen on the client. And so the client will become sluggish if it gets larger and larger and larger. And this is something that you will notice over time. And when you don't have the original experience, you will bring everything. But you can imagine that if your collection has, even a few hundred megabytes to a gigabyte of data, how this can be a problem. So you will notice that what Jan has done is he not only limits the amount of data to 250, you could set that window to, it could be a couple of thousand, it should still be okay.
Yeah.
But he limits it to a certain amount of documents. And then on top of it, he only takes a certain amount of the fields that he has written to each of these documents. So he's not taking everything. So you could also imagine having a complex, employee document, for instance, that has the employee ID and then all sorts of information that you might have about that employee, and maybe their performance history is a sub-document, and you have many, many years of this. And if you have many employees, you can have this as an issue. Same with, a CRM application that you might build, or a product ordering system, or an inventory system. So part of the practice, and this is not just Meteor, this is just good software practice, is to only take the information that you want and that you can use into the system and limit the size of that information to make sure that your application is performant. So this is not something that you were necessarily emphasizing in the example, but this is a practice that you embedded in the example. And I wanted to point that out because I think it's super important.
Totally. And I think Meteor, the guide and the docs and API docs, and everything around Meteor tries to help you to understand that and conveys you to use these practices. And I think at that point, we might end now, and hope you enjoyed the tutorial. And please let us know.
One last thing I think you should also mention is that there is a related document that this tutorial is based on.
Oh, yes,
I don't think you mentioned.
Yeah, there is a written version of this. So if you don't like to watch so much, but want to rather have a written version of it, there is the article on dev.to, which is actually the website where I publish lots of my articles. There is also the written version of this tutorial for you to check out. And you could even simply copy pasta everything and then just run it. But of course, it tries to give you a little bit more understanding and context, has also all the links to the important libraries, and also regarding head requests or things like this. And I would also like to mention, this video is part of our MeteorJS community channel, and we're doing lots of videos around Meteor, streams, deep dives, hot topics. If you're interested in that, keep on and subscribe so you will get notified when the next video is coming out. Hit the like button so we know that this video is some value of you. And if there is something you didn't understand or you want to discuss with us, just add some comments. We're there, and we would like to talk. We love to talk.
And there's one additional thing I think you should add here, if you can. Is there a GitHub repo for this project?
For this project, there is no GitHub repo.
Oh, okay. I made a
Plot.
mistake.
Yeah, if
We will
somebody,
cut this from the video.
yeah, no. If somebody, so let us know in the comments if you would like to see this as a GitHub repo. Maybe we could start this as a open source monitor solution starter. I know if somebody wants to collaborate, I'm really open for that all the time. I really like the idea. It's just there needs to be someone who's interested in that. If you're interested in that, leave a comment. I would be very happy.
All right.